Hello, I'm Patty Simpson, and today we're going to continue our conversation about permutations versus combinations. We're going to look today at the formula for both permutation and combination, and we're going to see why the formulas work for each one. So last time in our video we talked about the fact that permutation we use when order matters, and combination we use when order doesn't matter. And we have the formula here for permutation, where N represents the number in our group, and R represents the number that we are choosing. So for this formula, it tells us that we're going to take the number in our group, take the factorial of it, and divide that by the number in our group minus the number we choose, the factorial of the difference there. That's permutation. Combination is almost identical. Has the same notation of N means the number in our group and R means the number that we are choosing. And it's the same idea where we take the number in our group, the factorial of it, and we divide it by the difference between the number in our group and the number we're choosing, the factorial of it. The only difference is we also divide by the number that we are choosing, the factorial of it. So it has one more little number in there. And let's see if we can find out why that is. So I have an example here where there are four friends: patience, temperance, honor, and charity. Oops, that makes four. They're in a race, and we want to know how many different ways they can come in either first or second place. Now, because those places are orders, and the order matters there, being in first place is different than being in second place, we're going to use a permutation. So because order matters, we use permutation. And just to kind of get familiar with the notation here, our N tells us how many are in the group. And in this case, we have four friends, so there are four in our group. And the R is how many people we are choosing. In this case, we're only looking at first and second place, so that's two that we are choosing. So before we use the formula though, let's just look and see how many different ways they can come in first and second. Let's just go through and list all the ways that they can come in first or second. I'm just going to use their first initial to help me, and let's just look and see. Patience could come in first, and temperance could come in second. Or patience could come in first, and honor could come in second. Or patience could come in first, and charity could come in second. Those are all the different ways where patience could come in first. Let's do it with temperance now. Temperance could come in first, and patience could come in second. Notice that this is different than that because the places were different. Here, temperance could come in first, and honor could come in second. Temperance could come in first, and charity could come in second. Those are all the ways that temperance could come in first. Let's do honor. Honor could come in first, and patience could come in second. Again, notice that that is different than this because their places are different. The order matters there. Honor could come in first, and temperance could come in second. Or honor could come in first, and charity could come in second. Again, this one is different than that one, even though it's the same people, because the order here matters. Charity could come in first, and patience could come in second. Charity could come in first, and temperance could come in second. Or charity could come in first, and honor could come in second. So those are all the different ways that they could win the race. So we have a total of 3 times 4, 12 different ways that these friends could come in first or second place. I'll show you with the formula here in a minute, but let's look and see. Same situation where we have the same 4 friends, but now Prudence's mother says, hey, you can choose 2 of those friends for a sleepover. So Prudence wants to know how many different ways she could choose 2 out of the 4 friends. In this case, the order doesn't matter. Whether they're chosen first or second, they still end up in the sleepover. So let's look at the different ways she could choose. She could choose patience and temperance. She could choose patience and honor. She could choose patience and charity. She could choose temperance and patience. Oh, wait a minute. This is the same as having patience and temperance over. Because the order doesn't matter, this group is the same as that group. So that's not another way. It's the same as that one. But she could have temperance and honor. We don't have that in the group. She could have temperance and charity. We don't have that one yet. She could have honor and patience. Oh, wait a minute. We already have honor and patience here coming over. She could have honor and temperance. Oh, wait a minute. We already have that one here because that's the same group. Honor and temperance, or temperance and honor coming over is the same thing. But we don't have honor and charity. And we have charity now with every one of our partners. So in this case, there are only 6 different options for Prudence to have to choose 2 of those people. So notice that when order matters, we actually end up with more possibilities. When order doesn't matter, we have less possibilities. With the formula, when we divide by this extra number down here, this r factorial, it makes our number smaller. Dividing by that number is going to make it smaller. So that's the reason that our combination has an additional number on the bottom. Now let me just show you quickly the formula for these 2 problems, and then in the next video I'll do some more difficult examples. So here I'm just going to plug in. Our n was 4. We decided it was a permutation because order mattered, and our r was 2. So everywhere I see an n, I'm going to plug in that 4. So I had 4 minus the 2 factorial. So remember that factorial, what I'm doing is taking all of my numbers and just multiplying from 1 up to this number. So this 4 factorial means 4 times 3 times 2 times 1. On the bottom here I have 4 minus 2, or 2 factorial. I'll go ahead and write that out. So I have 4 times 3 times 2 times 1 over this factorial means 2 times 1. This 2 divided by that 2 gives me 1, and 1 divided by 1 gives me 1, so that I end up with just 4 times 3, or 12 different ways. Hey, we found all 12 of those ways. In this case, we'll use the combination formula because here order didn't matter. But same idea, we still had 4 people in our group. We're choosing 2 of them. So here I put the 4 factorial on top. My r there is 2 factorial. And then my n minus my r, and I'm going to find the factorial of that. So that I have 4 times 3 times 2 times 1 on top. On bottom I have 2 times 1, and then I have that times 2 factorial, or 2 times 1 again. Here this 2 and that 2 become 1. This 1 and that 1 are 1. This 4 divided by that 2 is 2. And 1 on bottom just gives me a whole number. So on top I here have 2 times 3, which is 6, divided by 1 just gives me the 6. There are 6 different ways, and sure enough, there were 6 different ways for us to invite our friends over. So hopefully that gives you a little more idea of when to use and why the formulas work the way they do. For combination, you just have one additional number that you're dividing by to make that number smaller, because when order doesn't matter, we have less choices. In our next video, I'll do some more difficult combinations or combinations and permutations and use the formula. Till next time.